In this video, we want to take a look at the quadratic formula, which is an important tool for finding zeros of quadratic functions. So remember, a quadratic function is anything that looks like f of x is equal to ax squared plus bx plus c. And when we're trying to find the zeros of any function, but a quadratic function in particular, we always set that function equal to 0. So it would be f of x, which is equal to ax squared plus bx plus c equals 0. Because remember that f of x is the same thing as y, and zeros are places where we cross the x-axis or y is equal to 0. Hence, finding zeros means f of x is equal to 0. So in our previous video, I'll just write this again, we did look at finding or actually completing the square, and that could be used to find zeros. But here we want to look at something called a quadratic formula. So here's our function again in general. And so the quadratic formula says that the solution, x, when we set this equal to 0, of course, is equal to minus b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. Now this portion of the formula over here underneath the radical is what we call the discriminant. And so the discriminant is b squared minus 4ac. So there are three possibilities for that discriminant. And they're important because the discriminant lives underneath this radical, right? This is the portion of the formula, b squared minus 4ac. And so there are conditions, because there are only certain things we can take the square root of if we're talking about real numbers. But the conditions are, and let me just put that formula back over here. Let me do this. Let me erase this and put the whole formula here. So x is equal to minus b plus or minus square root b squared minus 4ac all over 2a. So let's look at some possibilities. One possibility is that b squared minus 4ac is equal to 0. If that's the case, then our quadratic formula becomes x is equal to minus b divided by 2a, because the b squared minus 4ac becomes 0. And so this implies that we have two repeated roots. Because we would get two solutions, but you see that the only thing that comes out is x is equal to minus b over 2a. So that's all we get for that when we have b squared minus 4ac is equal to 0. Okay, so let's look at some of the other possibilities. Take my formula there. Paste it up here at the top. And so another possibility is that b squared minus 4ac is greater than 0. If that's the case, then the stuff underneath the radical is greater than 0, so I get solution that's plus or minus, right? X is equal to minus b plus or minus square root of b squared minus 4ac over 2a. So I will get two real roots. And in this case, they will be distinct. That's if b squared minus 4ac is greater than 0. Okay, and the last possibility is if b squared minus 4ac is less than 0. In this case, I do have a bit of a problem if I'm talking about real numbers, because again, here's my discriminant, b squared minus 4ac. If that's less than 0, then that means I'll be trying to take the square root here of a negative number. And we know whenever we get the square root of a negative number, that will give us what we call a complex number. And we'll study those later on in the semester. But then this would give me that x has say x, the solution x will be complex. So let's just recap. B squared minus 4ac equal to 0 implies I get 2 repeated roots, right? B squared minus 4ac greater than 0, 2 real roots. Of course, in this case, the 2 real roots won't be repeated because that's the case where it's 0. And then finally, b squared minus 4ac less than 0, we have complex roots.